Every insight deserves an audience. Welcome to Atypica AI. Google just did something that should terrify Nvidia, and most people completely missed it. While everyone was obsessing over ChatGPT and AI chatbots, Google quietly turned its internal supercomputer chips into a commercial weapon.
I'm talking about TPUs, tensor processing units, and their latest version, codenamed Ironwood, isn't just competitive with Nvidia's best chips, it's potentially about to reshape the entire AI industry. After diving deep into this story, interviewing industry insiders, and analyzing the real numbers, I can tell you this: we're witnessing the end of Nvidia's monopoly, and the implications go way beyond just chip wars. Let me start with the number that made me sit up and pay attention. Google's new TPU can connect 9,216 chips into a single computing cluster. Nvidia's best setup, 72 chips. That's not a small difference. That's a completely different league of computing power. We're talking about 42.5 exaflops of computing power versus Nvidia's 0.36 exaflops. But here's what's really interesting. This isn't just about raw power. It's about what happens when you combine that scale with dramatically lower costs. You've probably heard that AI training is expensive. What you might not realize is that the biggest costs aren't the chips themselves, they're the electricity bills. A high-end Nvidia GPU burns through 700 watts of power. Google's TPU? Around 200 watts. That's not just better for the environment, it's a massive competitive advantage. When you're running thousands of these chips 24/7 to train the next breakthrough AI model, energy efficiency becomes your biggest cost factor. But let me tell you what really convinced me this is a game changer. I spoke with engineering leaders at major AI companies, and they're all saying the same thing. The old rules don't apply anymore. One AI systems architect told me flat out, for the largest training runs, it's no longer about whether TPUs are good enough. It's about whether you can afford not to use them. Now, you might be thinking, if Google's chips are so much better, why isn't everyone using them already? Here's the catch, and it's a big one. Nvidia doesn't just sell chips. They sell an entire software ecosystem called CUDA that virtually every AI developer knows how to use. It's like switching from iPhone to Android, except imagine if switching required rewriting all your apps from scratch and retraining your entire development team. This is what experts call Nvidia's moat, the protective barrier that keeps competitors out. For years, this software advantage was insurmountable. Even if competitors had better hardware, the switching costs were too high. But here's where Google is playing chess while everyone else is playing checkers. Google isn't just improving their hardware, they're systematically dismantling Nvidia's software advantage. They've created something called OpenXLA, which basically translates AI software to work on different chips automatically. More importantly, they've convinced some of the biggest names in AI to make the switch. Anthropic, the company behind Cloud AI, signed a deal to access up to 1 million TPUs. Meta is exploring TPU partnerships. Even OpenAI is reportedly in discussions. When I interviewed a strategy executive at a major tech company, she put it perfectly. These aren't just customer wins for Google, they're proof points. When Anthropic bets their entire AI roadmap on TPUs, it signals to everyone else that this technology is ready for prime time. But let's talk about what this really means for the economics of AI. I built a detailed cost analysis comparing TPUs and GPUs for large-scale AI training, and the numbers are striking. For a typical large language model training run, TPUs offer roughly 4 times better performance per dollar spent. That's not a small edge. That's the difference between a project being profitable or not. Here's where it gets interesting for you.
This isn't just about big tech companies saving money on their electricity bills. This shift is about to change who can afford to build cutting-edge AI. Right now, training a state-of-AI model costs tens of millions of dollars, putting it out of reach from most organizations. TPUs could cut those costs by 70 to 80%. Suddenly, universities, smaller companies, even well-funded startups can compete with the tech giants. I know some of you are thinking, this sounds too good to be true. What's the catch? The catch is real, and it's significant. Switching to TPUs isn't like swapping out a graphics card in your gaming PC. It requires completely rewriting your code, retraining your engineering team, and rebuilding your entire development workflow. One deep learning developer I interviewed compared it to learning a new programming language, technically possible, but painful and time-consuming.
But here's what's changing that calculation. Google is no longer fighting this battle alone.
When major AI labs like Anthropic commit to TPUs, they're forced to solve all these software problems. And because AI research is built on open collaboration, those solutions get shared with everyone. Every tool, every optimization, every debugging technique that Anthropic develops for their TPU clusters becomes available to the broader community. This creates what economists call a network effect. The more companies that use TPUs, the easier it becomes for the next company to make the switch. Google is essentially using their biggest customers as co-developers of their ecosystem. Now, you're probably wondering, what does this mean for Nvidia? Are they doomed? Not exactly, but their world is about to get much more complicated. For the past decade, Nvidia has enjoyed something close to a monopoly in AI computing. They could set prices, dictate terms, and customers had no choice but to pay. That era is ending. Based on my analysis, I believe we're headed toward a bifurcated market. TPUs will dominate the high-end, the massive training runs, the scenarios where scale and efficiency matter most. But Nvidia will likely maintain their grip on the broader market, enterprise AI, research labs, applications where flexibility and familiar tools matter more than raw efficiency. This isn't necessarily bad news for innovation. Competition drives progress. Already, Nvidia is being forced to improve their power efficiency and rethink their pricing. Google's competition is making the entire AI ecosystem better and more accessible. So what should you do with this information? If you're working in AI or considering it, start learning about both ecosystems now. The future belongs to engineers and organizations that can navigate multiple platforms, not just the dominant one. If you're investing in AI companies, look for those building platform-agnostic solutions. And if you're a business leader thinking about AI adoption, understand that your infrastructure choices today will shape your competitive position tomorrow. The era of single-vendor dominance in AI computing is ending. What's beginning is something much more interesting, a truly competitive market where innovation matters more than incumbency. Google didn't just launch a new chip, they launched the future of AI infrastructure. And based on everything I've learned, that future is arriving faster than most people realize.
Want to learn more about interesting research?
Check out
Anthropic AI.